Today we have a car that has a low boost situation with the famous code 4530. That's a BMW code which is for underboost. Many reasons for that code: vacuum leaks, boost leaks, plugged exhaust, sensors not working. So what we found first is the boost sensor popped out from its seat, so we replaced that. Now we're going to we took all the airbox cover, cowl, we took all the vacuum lines or cut a lot of them. So we're gonna test different components one at a time. Right now we're gonna test the system vacuum, what the vacuum pump produces. So we capped one end and then we hooked up a little vacuum gauge to another end. So we're gonna test that now. So we're testing the vacuum. You can see a system vacuum is 29 inches. You can see here that the system is holding vacuum, and this is the driver side of the system because we capped this off. So that means that this valve is tight on the EGR cooler, and then the valve for the motor mounts is tight, and then the brake booster check valve is tight, and this valve is tight. So that's good. That's a confirmation for us that the driver side of the business doesn't have any leaks, so we didn't need to go there. So now we're going to work on the turbo controller side of the system and then see what happens there. We'll probably just end up replacing all the lines and test different vacuum actuators and the valves. Could be a pressure converter, so we'll see. We're going to test the turbo switchover vacuum actuator for tightness. Make sure it holds vacuum. This big can here. And what we're going to do is we're going to cut this line because this is the output from this pressure converter. That's for turbo switchover. And excuse my hands. So we're going to cut it like that here. And this line is going to give us access to the big vacuum box for turbo switchover. So we're gonna put a T in there and test that, make sure that holds vacuum. So what we've done is we basically put a little connector here. So this passenger side is the output, driver side is the input on the pressure converter, okay? The output was a blue dot. You can't see the blue dot on it, but usually they come with a blue dot. So now what we're gonna do is we're gonna use the hand pump. We're gonna pressurize this, watch this rod. It's supposed to start moving. So let's see. It starts moving. This is at about 5 inches of mercury. And we're gonna pump it to about 20 or whatever we can and make sure it's holding vacuum. It's holding vacuum. No problem. Done. And now we can disconnect. Watch the rod. So just for explanation, when the rod is in relaxed position like this, it's completely open to the big turbo, to the low pressure side. When the rod is retracted fully, then it's completely closed and only exhaust goes to the small turbo, to the high pressure turbo. So just to make sure that that's clear. Okay, so that works. Now what we're gonna do next, we're gonna test the tightness for this vacuum box. So that's another way to do it, and just make sure there's no cracks. So we put a little silicone cap on there, and we're gonna pressurize it. "20 inches is fine." When I move this, it moves a little bit, but so there's no cracks in the vacuum accumulator box. There's nothing inside, just a plenum. So input, output, or vice versa, doesn't matter. There's no check valves or anything like that in there. So this one's good. Now we're also going to test the vacuum actuator for the compressor bypass, that little thing there. With a nipple here. So we already cut the line off there. We're gonna fit the nipple here, and that is a switchover between small and large turbo, between high pressure and low pressure turbo on the air side, on the pressurized air side, on the compressor side. You can hear a little click. That means it opened. And holding vacuum, no leaks, good stuff. There you go. You can even see this moving. So vacuum actuators are good. We can test also wastegate. So this is a line that goes to a wastegate. So that's going to test the vacuum actuator. And just something to also mention is when we test vacuum actuators, it also tests the flap. It's important to listen to a squeak or a little click of a flap to make sure the flaps are not stuck. Wastegate usually doesn't get stuck, but compressor bypass, especially in European models, gets stuck quite often. A lot of Europeans experienced it, maybe because they're older, maybe because it's a little bit different design. So just something to watch for. A wastegate needs a lot of vacuum to open. This car is fairly low miles, so sometimes things don't squeak and you can't hear it very well, but you can see it's holding 26 inches. And it's fine. You can disconnect that. So all of our vacuum actuators, vacuum accumulator box works. So we're just gonna also test the compressor bypass EL valve. We already tested the driver's side of business with the EL valves in there already, so we know there's no leaks there. So our problem somewhere here could be pressure converter, could be a cracked line, could be misrouting, could be a EL valve leaking. They leak sometimes, and that's basically where we are with trying to diagnose the code 4530. Next, we're going to test the electric switchover valve. It's called the EL valve. I guess it's in German, but it's basically an on-off valve. So it has two ends to it. It has a input nipple, which is facing straight, and it has an output nipple, which is facing sideways. I think we've done a little video for testing of these, so it's somewhere in our library there. But this car has 3 of these, one for the EGR cooler, one for motor mounts, and one for compressor bypass switchover that feeds that compressor bypass flap that we've already tested. So we've tested this side of business, the driver side, and we know that these 2 that we have for the EGR cooler and motor mount are good. They're tight. Now we're going to test the one for compressor bypass, and what we've done is we cut the lines off. So this is an output line, this is the input line. The output's usually red on factory cars, so we know that this one is going to the EL valve in the back there, so we know that this is the line. So unless they're crossed over, it needs to hold vacuum. So we're going to put a little fitting. I'm going to put our hand pump on it, and it's not holding vacuum. So unless the lines are misrouted, it's basically a dead valve. So we're going to extract that and test it again and then see what happens. And to extract it, we're actually not going to take this box. We're going to do it blindly. So usually if you don't know what you're doing, you have to take this whole bracket off, which is a little bit of a work, especially on stock cars with all electrical connectors, but we're going to avoid all of that. We're just going to undo the electrical connector and pull the valve out. Okay, so we retrieve the EL valve. It's mounted exactly like this, so you just have to unclip this. As you can see, we haven't taken the bracket off, so you just undo the electrical connector and then take the valve off. You just basically undo this and slide it out. So lines are routed correctly. Output line to the side, input line to the straight. So what we found is this crack in the hose. So chances are the valve is okay, but maybe the hose got dried out and overstretched, or maybe, yeah, it's quite brittle, we could see. So that's probably the problem, and ultimately will contribute to the 4530 very easily, because they both fed from the same vacuum accumulator box and then on the same line as the pressure converter for the turbo switchover. So we're going to take this line off and we're going to test this EL valve. It's aftermarket, it's been replaced by the owner, so chances are it's probably fine. They do leak eventually, but this one's fairly new, so probably good. So we're going to test that, and we're going to pressurize it, and it holds vacuum. So this Yale valve is fine. It was just a cracked line. The reason for our 4530 code. So we may as well show you how we fit this stuff back in, because that basically will be an indicator or a little guide of how to do vacuum lines without taking this bracket off. So what we've done, we undone this a little bit just to the side here, so it's a little bit more space, and we've cut the length of vacuum line. You could just do it approximately. Of course, it uses a bit more vacuum line for the input nipple, and then for the output nipple, this is the long one because it goes here to the compressor bypass. So we're going to fit this back in. I'm going to show you quickly a bracket that it goes on. So this bracket it sits on, it's a separate bracket from this that the vacuum accumulator box on. And what happens is it gets clipped in like this. So this clip goes through the slot and gets pushed back towards the back of the vehicle, and it's facing the driver's side of the vehicle. So what we do is we will sneak it underneath here, and you just have to watch your vacuum lines. So what you do is you feed it with the line first, so it doesn't get lost. So here's your input line, and you just pull it through in the correct orientation. Okay, and there it is. You could see it. Okay, so this bracket is good to be loose, the main bracket, but you can't fit that Yale valve when you're trying to. There's the Yale valve, it's fitted, right? So it got a clip here, and the little end's gotta stick out there. I'll show it with a screwdriver. So this is how you know the little plastic end here on the slot. There's a slot there that it's gotta stick out there. So once you fit it in is good, but you can't fit it in with this bracket being like that, because that fourth little ear for the fourth bolt is gonna interfere. So you gotta put it in all the way. You can put the bolt on, and then you gotta slide it through. You can put a bit of silicone grease on it, make sure that it slips. And then what you need to do, you need to pull your lines. So this is your feed line. Make sure it doesn't get pinched, or make sure it's got enough of the slack here, because that was, I think, was our problem at the very beginning, is maybe it was too stretched, and then once it dried out a bit, it cracked. So make sure it's got enough slack. And then the line that you also fitted here, this is your output line. Make sure that it gets also enough slack here, it's not pinched anywhere, and then you slide it through this little bracket here. So there's a little plastic bracket here. You can up like that. Make sure it's got enough of the slack, and then this electrical wire gets clipped into it after, like that, and then you're good. So that's your two lines there. Just a quick video. I think this has been covered so many times, but we thought we'll throw it into the video. So we cut the two lines, or the ends of the two lines left on this pressure converter. This pressure converter is for a turbo switchover for the big can. And we've already fitted a little silicone line to the big can here. The reason we did silicone here is because it's a little bit easier to take off, and then that nipple on the big can is easy to break as well. It's metal, but they do break off. So we just did a silicone line here, and then we'll feed it into the output of this pressure converter. But just a quick video to show that this is how you should be cutting old vacuum lines. So you take a X-Acto knife, hopefully sharp, and you cut it along like this. So gently, not to break the nipple, and make some incisions. And what you do then is you try to peel it. You know, maybe I need a little bit more. So we just cut it off, and then try to peel it off a little bit like this, open it like a jacket, and then it comes off. So, and then you haven't damaged anything. So this is the wastegate pressure converter, this is a turbo switchover, and we're gonna start routing the lines now, and we'll show you how as well. First we'll put this bracket in its place. This silicone line, the blue line that we're gonna pull it up through here, we're just using like a little 90-degree hook for a little pick, so it's easier. So once we route it here, we'll put it on the output nipple of the pressure converter. You can just lower it a little bit like that, so it's not being pinched anywhere, and check it, make sure it's all routed good. So this is the compressor bypass one. I'm just gonna pull it up, and I'm not going to connect it at this point because I want to put the air box and everything, so it's gonna be one of the last ones to go, but I'm gonna route it here first. And just give it a bit of slack there, a little bit like that. I'm gonna put it to the box here like this. Next, so together with this line, we're gonna put that through the T. I'm gonna put this on, and this is gonna come from a T here. So maybe the T is gonna be here. I'm just gonna cut it here. So this is the output from the vacuum accumulator box, and then it's gonna go into our T here. So we're just gonna cut this. Now this guy is gonna go underneath here, and maybe enough slack here. So there's gonna be a T. These three is gonna come to the T like that. Now this guy, I'm gonna do it like this. Okay, so this is gonna be our feed into the pressure converter for turbo switchover. That's coming from the accumulator box. The other feed is gonna be from the compressor bypass feed. The waste gate in is this nipple here, the one on the driver. So like that. Make sure it's not overstretched here. And then this is the feed, and it's gonna come around here. Or the feed into the vacuum accumulator. So be careful with plastic nipples. I'm using silicone grease on here just so it slides nicely. So this is a wastegate output from the nipple that's with a blue dot that's facing the passenger side. So it's just right under this line. So I'm gonna fit that in there. Okay. So wastegate output, we just routed it underneath these hoses and underneath inside the oil, turbo oil hose, and then it's gonna get clipped to this line here. And we just need to have enough length for it to connect to the nipple there. This guy, this is a little heat shield for the lines. So we're just gonna put them flat in here. Compressor bypass line, just we routed also under the oil line, clips into a larger clip here, a larger clip here. And just we'll spray it with silicone grease, and then hook it up to this nipple here. It's got to be the right length so it doesn't interfere with the AC fan. There we go, that's it. This is the condition of the old vacuum lines, and these are replacement lines as well, so they've been on a vehicle for a year, and they're just nice and crispy like that. So we've replaced a lot of them now on the passenger side for turbo control. Some of them were a bit more flexible. And owner reports that the boost is back. Yeah, this is what you get, you know. But it's not it's not indicative of a quality of these lines. There's nothing wrong with these lines. It just shows it's a wear item, and especially above the turbo, they get very plasticized like that, and we basically just need to replace them. But the main lesson here, I guess, from this replacement is that you got to route them carefully. You got to route them with a little bit of a slack. You got to make sure you don't pinch anything, especially with silicone lines, which are a bit softer. With these rubber braided ones, they're great lines, but you got to make sure that you don't overstretch them somewhere, because once they start drying out they could crack, and that was basically the case with us. So anyway, we're glad we found the problem, and the vehicle is going to be healthy for a while now, and it's not going to have any boost problems, hopefully.